All right, good morning, everyone. Today we're taking on a little review for Quiz 8. So first up, I'm having you start with, can you find the surface area and the volume of a cube with a side that measures 4 square root 3 inches? So first, I'm just going to lay out my two formulas. I know that my surface area is 6 times a side squared. I have 6 perfect squares, and my volume is a side cubed. So I'm told that each side is 4 root 3 inches, so that's what I'm plugging in. So I have 6 times 4 root 3 squared for the surface area, right? That exponent of 2 goes to both items, like so. So I really have 6 times, well, 4 squared is 16, and then root 3 squared is 3. So I'm saying 6 times 48. And 6 times 48 will get me 288. So my surface area is 288 inches squared. Okay, volume, I'm plugging in that 4 root 3 into parentheses, and I'm raising it to the third power. So here, I know that that's going to be 4 to the third power because, again, that 3, the exponent of 3, applies to both items. So 4 to the third power is 64. But then I have the root 3 times. Let me write it out like that. So I know that when I have 2 square roots, like so, and I'm multiplying the same number underneath, like root 3 times root 3, it's going to give me a pair of 3's underneath the same radical. So the square root of 3 times the square root of 3 is just 3. So I'm going to end up with 64 times 3, which is 192, and then times the square root of 3. So I get 192 square root 3 inches cubed for volume. All right, next, going back to our trapezoids. So trapezoid has a base of 12, a height of 8, an area of 100 square centimeters. Find the length of the other base. Okay, so first just laying out my formula. It's a trapezoid, so I know that my area is the average of the bases times the height. So 1/2 parentheses, base 1 plus base 2, close parentheses, times the height. So I'm plugging in the area of 100. I'm going to plug in one base. I'm going to call the other one x just to simplify things. And the height is 8. So now it's just an algebra problem, and we're trying to isolate the x. So here there's a few different ways that we could approach it. For me, I like to multiply the 1/2 by the 8 first. So I have 100 is equal to 4 times 12 plus x. That's my choice. There are other paths you could take that would lead us to the same end result. So now I could distribute the 4 or I could divide it away. So if I divide each side by 4 next, now I have 25 is equal to 12 plus x, and then I take the 12 away from each side, and I get that x is 13. So my missing other base had to be 13 centimeters. Okay, next here we have a circle. So our circle has an area of 200 pi centimeters squared. We want to find its circumference. So a circle has an area of pi r squared. We're told that the area here is 200 pi. We want the circumference, and circumference is 2 pi r. So clearly what we need is the radius. So to find it, I know that pi r squared is equal to 200 pi. I'm going to divide each side by the pi. Now my radius squared equals 200. So I can solve by taking the square root of each side. I know that 200 is 100 times 2. So my radius is plus or minus 10 root 2. And it always has to be the positive. It's a measurement. We know how this works. So my radius is 10 times the square root of 2. So that's what I'm plugging in right here is 10 times the square root of 2. So when I'm multiplying across, I'm multiplying the 2 times the pi times the 10 times the root 2, just like that. So I'm going to multiply the 2 times the 10 and get 20. I'm going to put the pi next and that square root of 2 last. Just again, so there's no confusion about is the pi meant to be part of the radicand, the number underneath the radical, or not. So I'm just pulling it out in front so there's no confusion. So I have 20 pi times the square root of 2, and my units are centimeters. All right, next up, keep sliding. Okay, so the base of a right triangular prism is an isosceles right triangle. Big detail, I'm going to underline that. The hypotenuse is 6. The height of the prism is 10 centimeters. Find the surface area and the volume. Okay, so again, we want to draw this thing out. It's good to visualize it. So I'm going to draw my base shape first. So I'll draw out my isosceles right triangle. So here, right triangle, 2 legs are the same. Now it's isosceles. I'm going to mimic here the back of it and then the front of it. So now I have my 2 bases. And then I'm going to draw in all of those lateral edges. Okay, those little dotted markings for the background. Okay, I'm going to label what I'm told. I'm told that the base is an isosceles right triangle. The hypotenuse here is 6. The height of the prism is 10. So I want those markings to be perfectly clear because one is talking about the base, the hypotenuse of the base, and the other is the height of the prism itself. So next I'm going to focus on my base shape. So here is my base. An isosceles right triangle, this part is 6, which means that these angles, they both have to be 45 degrees. So I know that my legs are both x, and the hypotenuse is the x root 2. So if I take half of 6 and I multiply by the square root of 2, these 2 legs have to be 3 root 2. All right, so now if I want my base area, it's a triangle, so 1/2 base times height. My 2 legs are my base and my height. They're the perpendicular segments for a right triangle. So I'm saying 1/2 of 3 root 2 times 3 root 2, which is like saying 1/2 times 3 times 3 times 2. So I end up with 9 centimeters squared. That is my base area. Again, I know that these 2 legs are both 3 root 2. I'll add that to my big picture. So now I'm ready to keep going and get to my surface area and my volume. So my surface area is the height of the prism multiplied by the perimeter of its base plus my 2 base areas. Volume is base area times the height. So my height of the prism, that's 10. The perimeter of the base, so if I add these up, I get 6 plus 6 root 2, and my base area is 9. So that's what I'm plugging in. 10 times, in parentheses, 6 plus 6 root 2, and then plus 2 times the 9. I can distribute the 10, so I have 60 plus 60 root 2 plus 18. I can only combine the like terms, so I get 78 plus 60 root 2. My units are centimeters, so centimeters squared. So 78 plus 60 root 2 centimeters squared. Okay, volume, my base area is 9. The height of my prism is 10. So that's a pretty easy calculation. It's just 9 times 10, and we get 90. So 90 centimeters cubed. Area is always square units. Volume is always cubic units. Next up, the base of a right regular hexagonal prism has a perimeter of 60 centimeters. The volume is 4,250 root 3 centimeters cubed. Okay, so let's just write out what we know. We know the base shape is a regular hexagon. We know its perimeter, and we know the volume of the prism. So we know that the volume is base area times height. We currently know the volume. I know the volume is 4,250 root 3 centimeters cubed. I have enough information to get to the base. I just actually have to draw it out and solve for it. So if I focus on my base shape right now, I know it's a regular hexagon. Boom, there's my regular hexagon. My perimeter is 60 centimeters, so I need to split that 6 ways, and each side has to be 10. So then if I draw in my apothem and my radius, like so, I know that right here is 60, here is 30. So x root 3, 2x. So I know that right here is 5. So my apothem is 5 root 3. So I can find my base area. I know that my base area is 1/2 the apothem times the perimeter. So 1/2 of 5 root 3 times 60. So half of 60, I'm going to multiply that first because I like to take half of the even number. So 30 times 5, and I get 150 root 3 centimeters squared. So that's the area of my base. That's actually what's going in right here. So 150 root 3. So now, again, it's just an algebra problem. I need to solve for h. So I know that 4,250 root 3 equals 150 root 3 times h, times my height. So I'm going to divide each side of my equation by 150 times the square root of 3. So I end up really just having to divide 4,250 by the 150. So I'm going to get a height of 28 1/3. So my height is 28 1/3 centimeters. All right, let's look at that second page. So here I'm giving you some models, some as nets and some in 3D form. So first I'm looking at a trapezoidal prism, and I'm giving you its net. So I'm focusing on first just that top base. I want to get my base area, my surface area, my volume for each right prism or right cylinder. So let's focus on the base shape first. So let me draw out my base just off to the side. So I can see that it is a trapezoid. It's actually an isosceles trapezoid because these two legs are both 6. So I have a 6 here, a 6 here, a 10, and a 12. Okay, I know that to get its area is going to be 1/2 base 1 plus base 2 times the height. So right now, I know the two bases are 10 and 12. So I can plug those in, the 10 and the 12, but the height I don't know. That's that perpendicular segment that connects the top base to the bottom base. So if I draw it in right here, it would be the same as what it is right here. So I can see that, oh, Well, that 10 would really just slide down right here, which means I have 2 units left because this whole part is 12 and I have 10 already occupied. So 2 units, if I split it evenly 2 ways, I have a 1 right here and a 1 right here. So then I'm just using some Pythagorean theorem to figure out the height. So I know that 1 squared plus that height squared equals 6 squared. So 1 plus the height squared equals 36. Take away the 1, the height squared equals 35. I solve by taking the square root. I know that this would be plus or minus the square root of 35, but I'm only interested in the positive. So right here, the height of my trapezoid is the square root of 35. All right, so that is what's going in right here. So if I'm taking 1/2 of 22 and then multiplying by the square root of 35, I'm going to get 11 root 35, 11 root 35 units squared. So I've taken care of my base area. So now I need my surface area. So for surface area, I need the height of the prism times the perimeter of its base plus my 2 base areas. So looking at here my base, remember that what happens when we take a net and we make it go 3D, that 6 right here is the same as the 6 right here. The 6 right here is the same as the 6 right here. And that 10 would be a 10 right in here as well. So I can see how this is the height of my prism. This is the perimeter of my base because it wraps around the base right here. So that gets me this entire rectangle right in here. That lateral area becomes flat, this giant rectangle. So the height of the prism is the 5. The perimeter of the base, if I add this strip up this way, or if I wrap around and add it this way, either way, it's going to sum to 34. And then each base is 11 root 35. So I end up with 170 plus 22 root 35. So 170 plus 22 root 35, and my units are squared. Okay, lastly, looking at volume. Volume is base area times the height. So 11 root 35 times the height of the prism, which is 5, will get me 55 root 35. Units cubed. All right, next up here we're looking at a triangular prism. I can see my 2 base shapes here, both equilateral triangles, and I'm saying that up here as well. So the base is an equilateral triangle, the perimeter is 24. So again, let's take a moment, let's just flesh out the base shape. We have to make sure that we handle the base correctly. If I don't get my base area correct, it's going to throw off my surface area and my volume. So if my perimeter is 24, and I split that 3 ways, each side is going to be 8. So 8 all the way around. If I want its area, I could do it 2 ways because it's an equilateral triangle. So I can do 1/2 base times height, or 1/2 the apothem times the perimeter. I'll do 1/2 base times height. It feels easier to me right now. So I know that I can split it right down the middle and make 2 30, 60, 90 triangles. Here is my 60, here is my 30. 30 here, 60 here. So I know that right here would be x, which is 4, and then right here would be the x root 3, which would be 4 root 3. That's ultimately what I needed. So I know that my base is 8, my height is 4 root 3. So 1/2 base is 8, height is 4 root 3. So when I multiply across, I get 16 root 3 units squared. So base area is 16 root 3 units squared. Surface area next. Height of the prism, perimeter of the base, plus the two base areas. So height of the prism, right, that perpendicular segment here that would connect base to base, that would be the 20. So height of the prism is 20, perimeter of the base, 24. Two base areas, each one is 16 root 3. So 2 times 24 is 480, and then plus 32 root 3 units squared as well. So 480 plus 32 root 3 units squared. Okay, volume last. So volume is the base area times the height. So 16 root 3 times my height of 20, and I get 320 root 3. So 320 root 3, and my units are cubed. Okay, two more examples. Let me slide this up. So here in the next problem, here the base is a regular decagon. The apothem is 6. So that's telling me that my figure has 10 sides. So regular decagon, my figure has 10 sides. The end value is 10. So what that tells me is that I'm really going to have to use some basic trigonometry to be able to get to my perimeter. So here I know that, again, base shape is a regular decagon, 10-sided figure. So I know that I'm going to be using here this right triangle, where this is my apothem, this is my radius, and this is x, and x is half of a side. Okay, and I know that ultimately area will be 1/2 the apothem times the perimeter of my figure. I know my apothem is 6. That part is already given to me. Okay, so apothem is 6. Let me go ahead and label that as 6 right here. But I need to know what this angle is, and that's half of a central angle. So half of a central angle, let me write that here. So 1/2 of a central angle would be 1/2 of 360 divided by 10. So half of 36 gets me 18 degrees. So right here is 18 degrees. Okay, I'm trying to get to the perimeter, so I need to know half of a side right here. So using some basic trigonometry here, from this reference angle, I have an opposite side and an adjacent. So I'm going to use tangent. So I'm going to say that tangent 18 is equal to x over 6. So here's my proportion. I cross multiply, and x equals 6 times tangent 18. So I get that x is about 1.95. X is half of a side though, and I need my full perimeter. So if that's half of a side, I could double it. That gets me a full side, and then multiply by 10. So that would get me a perimeter that's about 39. Okay, so now that I'm here, I know that my area is going to be 1/2 times 6 times 39. So if I multiply that across, I get 117. So my base area is about 117 units squared. Okay, surface area next. Surface area. Height of the prism times the perimeter of its base plus the two base areas. So the height of the prism here is 13. So 13 times the perimeter of the base, we solved for that earlier, 39, plus the two base areas, right? Each base has an area of 117. So here, if I add that up, 13 times 39 plus 2 times 117, I get 741. So 741 units squared. Okay, volume, base area times the height. Okay, the base area, right, already solved for that, 117. And then height of the prism is the 13. So that gets me 1,521 units cubed. Okay, one last variation. So here it's a cylinder, and I'm giving you the top view of the base. So I know that a radius is going to be congruent to any other radius. So I have a radius here and a radius here. And since it's an isosceles right triangle, then I know that these angles have to both be 45 degrees. So then I have x, x, and x root 2. So if I take half of 10 and multiply by root 2, my radius has to be 5 root 2. Okay, so building off of that, to get to my base area, it's a circle, right? It's a cylinder, it's a circle. So pi r squared. So I'm doing pi times 5 root 2 squared. So that exponent goes to both items. So 5 squared is 25, root 2 squared is 2. So I'm going to end up with 50 pi. Base area is 50 pi units squared. Okay, surface area next. So here I'm looking at my circumference times the height plus the two base areas. So here I'm just plugging in for my radius, 5 root 2, my height, here's the height of the cylinder right there, 18. Radius again was 5 root 2. Okay, so here I'm just taking 2 times 5 times 18, I get 180. I put the pi next, and then the square root last. So I get 180 pi root 2 plus 2 times 5 root 2 squared, so 2 times 50 pi. So I get 100 pi. Okay, not like terms, so it stays like that. That's as simplified as I'm going to get it. So I have 180 pi root 2 plus 100 pi units squared. And volume, finish with the volume. So volume, base area times height. So pi r squared times the height. My radius is 5 root 2, and my height is 18. So 5 root 2 squared, that's 50 pi. So I have 50 pi times 18, and I get 900 pi. So volume is 900 pi units cubed. All right, I hope that was a good refresher on our cubes, our prisms, our cylinders, as well as going back just to some regular two-dimensional shapes as well. So we looked at our trapezoid, right? We looked at some circles. We just look at triangles. We look at all of those shapes that we learned early on because they're all coming back into play in surface area and volume. All right, have a good rest of your day.